All right, so we're going to take a look at section 7.6. It's called Common Logarithms. Okay, common logarithms. So in our society, we have a base 10 system. You know, when we go tens, hundreds, thousands, they're all powers of 10. 10 to the first, 10 to the second, 10 to the third. That's kind of the counting system we use. And so that base 10, is very common. And so a common logarithm is known as a log with a base of 10. So if we said log base 10 of b, I don't know, whatever the case may be, we would call that a common log. And we actually, because it's so common, we don't bother writing the base number. So that would just be log of, sorry, I shouldn't be writing a base number. Hold on a second. I would skip the base number altogether and just say that that means log of b. Okay? Doesn't have a lot of meaning to us right now because there's no number there. But if you ever see a log without a base number, we just know that that means it's a base of 10. So let's evaluate a couple. So if we see log of 10 with no base number, it means log base 10 of 10. So 10 to some power equals 10, so that's equal to 1. Log of 1/100th. So we know that 10 to some power is 1/100th. Well, 100 is 10 squared, but it's also in the denominator, so the exponent would have to be a negative 2. Log of 0.1, well, that would be 1/10. So we can take a decimal, make it a fraction, 1/10, and so that would mean the 10 had to go to the denominator, so it's just a negative 1. If we see log of 1, doesn't even matter what the base number is. If it's a log of 1, we know that the answer is 0. Anything to the 0 power equals 1. And so one last one of those. Let's go log of 1,000. So 10 to the first is 10, 10 to the second is 100, so 10 to the third would be 1,000, so this is a 3. So there are some common logs. You don't have to see the base number to use them. So if we go now to some solving problems, let's take a look at 3 to the x equals 15. So we have an exponential equation here. If I were to try to rewrite this, or try to think, I mean, if we try to figure out whether I can write both sides as powers of the same base number, we can't do it. 15 is not a power of 3. So we can't use the strategy we've used prior to this. And if I tried to switch it into log form, I would still have a log base 3 of 15, which I still don't know what that is. But a strategy to solve these, if you can't write them both as powers of the same base number, is you can log both sides. What that means is you simply write the word log in front of the left side. Write the word log in front of the right side. So you're taking the log of both sides. On the left side, we see that we've got log of 3 to the x. There's an exponent inside of a log. We learned this when we were expanding, that that exponent can become a coefficient in front of the log. So that's how I free basically the x out of the exponent. So I have x times log of 3 equals log of 15. So I logged both sides, and now I'm trying to solve for x, so I could divide by the log of 3. So what is x equal to? Well, it's equal to log of 15 divided by log of 3. What's log of 15 divided by log of 3? Well, we're going to go ahead and use a calculator to do that. We have a log button on our calculator. Okay, you can see right next to your 7, at least on these graphing calculators, right next, sorry, I'm trying to get that light up to not reflect on there. Right next to the 7, there's a log button. It doesn't have a base number. That's talking about a common log. So it's going to use a base of 10, and that's what I have here. So I'm going to do log of 15 I've got to close my parentheses because it started a parentheses when I hit log. Divide that by log of 3, and it will go ahead and give us our answer. So it's about 2.465, maybe I'd call it. So one more of those. Let's take 6 to the x equals 42. So we would simply log both sides. And I know that that x is now going to move in front, moves out of the exponent. So we have x times log of 6 equals log of 42. Now I can divide by the log of 6. So x equals log of 42 divided by log of 6. Pull out the calculator. Log of 42 divided by log of 6. And so x is about 2.086. I don't really, if the instructions tell you how many decimal places to round to, then go ahead and follow that. But I'm going to, roughly 2 or 3 decimal places is probably sufficient. I'm not a big stickler on that unless it says. I'd like to take a look at some inequalities. So let's go with 3 to the 5y is less than 7 to the y minus 2. Now this is actually one of the examples out of the book. So you can also see it in the book if you want to look back at it later, but I'll kind of walk you through it. So just like the last problems, I'm going to go ahead and log both sides. I see that the 3 and the 7, they're not powers of the same base. I can't make them the same number. So I'm just going to log both sides. And as I log the left side, that 5y becomes a coefficient. As I log the right side, that y minus 2 becomes a coefficient. Since it's a coefficient, I'm going to wrap it in parentheses. And now I've got to actually do a little bit of distribution on the right side when that coefficient is actually 2 things. I'm going to distribute my log of 7 to both of those. So let's rewrite that. So the left side stays the same. And so I'm going to call this y times log of 7 minus 2 log of 7. I just distribute the log of 7 to both of them. My goal in this problem is to solve for y. Right now I have a y on both sides of the inequality, so I need to bring them both to the same side. So I'm going to need to subtract my y log of 7 from both sides. So minus y log of 7. On the other side I'm left with just negative 2 log of 7. And so now, once again, my goal is to get y by itself. I can actually factor the y out here. So when I factor that out, I have y outside, and then inside I'm left with 5 log of 3 minus the log of 7 is less than negative 2 log of 7. Now at this point, I'm nearly done. I want that y by itself, so I'm going to have to divide this, the 5 log 3 minus log 7, to get rid of that piece, so then I have to divide that to both sides. So y is going to be less than that number. And so now I'll just pull out the calculator and I'll type that in. So I'm typing in negative 2 log of 7, close the parentheses. divided by, now in the denominator I'm going to need to put a set of parentheses around the denominator because there's multiple things there. So it's very important that we do a set of parentheses around the denominator. It's not necessary to do it around the numerator. You can do it, but the denominator has to happen. So 5 log 3 minus log 7. Then I can close the parentheses. It's actually, you don't have to close the parentheses since I'm done with the problem now, but not a bad practice. And we get negative 1.097. So we've got y is less than negative 1.097. I think the textbook went one more decimal, but that would be the solution to our inequality. Now we also, in this section, I'm going to go ahead and make a break here, have a change of base formula. So the purpose of this change of base formula is that if you have a calculator and all it can handle is a base of 10, then we can use this formula to change any base, any log, to a base of 10 so that you can use your calculator. Now some of your calculators actually don't actually need this. So prior to showing you the change of base formula, let me show you this little trick first on this graphing calculator. If I go to math, the math button, I think I have to scroll over to the second menu, the number menu. Oh, let's see, I might be wrong. Let me go back. I was thinking that's where, oh, sorry, it's under the math menu. I just had to scroll down. It's actually letter A, so it goes after 10. It says log base. If I chose log base, you may see that it gives me a spot where I can put whatever base I want and whatever number I want. And so I will be able to find other logs using that. But not all calculators have that. So if your calculator has this, honestly, I wouldn't worry about the change of base formula. But if you don't have that function, you may need the change of base formula. So what is it? We can say log base A of n. Really, we can use any letters we want there, but those are the letters the book used. You can break it into this fraction. Log of n divided by log of a. Notice I didn't write bases, so we changed them to common logs. Every calculator, at least every calculator that you have, hopefully, has a log button, so you should be able to do that now. Log of n divided by log of a. You have to remember which number goes to the top, which number goes to the bottom. I always say base to the bottom. The base number was a, that's the one that went to the bottom. Base to the bottom, so the n went to the top. So let's practice it. So let's evaluate log base 5 of 140. So I still have this log base up on my calculator. I'll show you real quick that I can simply change the base to 5, the number to 140, and I get, whoops, I hit the wrong button, and I get my answer. But let's use the change of base formula. The change of base formula says you can say log of 140 and divide it by log of 5. Let's see if we get the same answer. Log 140, close my parentheses, divide by log of 5. I do get the same answer, 3.070. Alright, that should give you a pretty good idea on section 7.6. The 7.6 homework will not be due until Friday because of the quiz, but there's your